In section 6.2, we're looking at reading graphs. Graphs are a visual way to display data. They're seen in various forms in our daily lives, from the media to school to our jobs. Understanding how to read and interpret the data in a graph is an important skill to have. Graphs often describe or summarize data very quickly with few words. And as the saying goes, a picture is worth 1,000 words. 4 different types of graphs that are common are the circle graph, which is sometimes called a pie chart. A circle graph is used to compare parts of a whole or percents of a whole. The bar graph is used to emphasize comparative amounts, so you're looking at comparing different data. A histogram is used to identify the frequency of the data in intervals or classes. Notice the difference in the pictures of the bar graph where the bars are spaced apart and the histogram where the bars are touching. And then we have a line graph, and line graphs are good to show trends over time. Graphs should be clearly labeled, they should be easy to read, and they should have appropriate titles. Here's an example of a good bar graph. As you can see, bar graphs compare amounts among different categories. The amount of money a movie makes in the box office is commonly used to determine how successful the movie was. Here's a bar graph to show the amount of money earned by the top earning movies from May of 2013. So let's answer some questions based on this graph. What does the vertical axis represent? The vertical axis is the up and down. Notice here we can see that the vertical axis is labeled as gross earnings. Whereas the horizontal axis, the left to right, shows down here the movie title. And so how can you tell which movie had the highest gross earnings? We look for the bar that is the tallest, and so we can see in May of 2013, Iron Man 3 topped the rest of them. So it doesn't specifically ask us which movie, but let's just mention it. Iron Man 3. Here's a good example of a circle graph, or again, sometimes you'll see it referred to as a pie chart. We're comparing parts of a whole. So tuition is one example, and notice that here we have the tuition for the College of Charleston in the 2013-2014 school year. And the only thing that is added that isn't shown here on the chart specifically in the description is that the whole represents $38,131. So the sum of all percents given in the circle graph should be 100%, because we know 100% means the whole thing. So verify this is true. So let's add. We have 1% plus 3, that would give us 4, plus 26 more would give us 30, plus the 70 will give us 100%. So again, that 100% represents a total of $38,131. So does the circle graph represent how the total is divided or just part of the tuition? And we know that it represents the whole thing, so it's the total tuition. Part of the tuition would be one of the segments of that. And if we look at the graph, we can see that there are 4 different categories. They're color-coded as well to make it easier to look at. A line graph is a graph that uses points that are connected by lines or line segments to show how an amount changes in value as time goes by. A line graph shows a change in yearly average tuition price at a public 4-year college. The amounts are based on the value of the dollars during the 2009-2010 academic year. And so the vertical axis, again, that's the up and down, we can see here is the cost of tuition. And the horizontal axis, left to right at the bottom, is the academic year. And notice it's showing every 10 years. If a trend is present in the data, it can be seen in the line graph. Is there a trend in this data? If yes, describe the trend. The trend is an overall tendency of the graph. And as you can see, if we were reading the graph from the earliest date, the 1980-81 to the 2010-11, the dollar amounts keep increasing. So even if there was a little bit of a decrease in some of the years, which we don't see because they're only doing 10 years at a time, overall, the tuition is increasing. So we say, yes, there is a trend, and the cost of the tuition increases as time increases, or you can say the academic year increases, which makes sense to us, that due to inflation and rising costs, the tuition rates would reflect that. The only one of the four common graphs that we haven't looked at yet is a histogram. A histogram is a common graph in statistics used to summarize large sets of data when the data are typically from measurements. This type of graph is commonly called a frequency histogram since it illustrates the frequency at which the data falls within certain ranges. Bar graphs are often used when data falls into categories and have repeated values, whereas histograms are often used for measurements of data that don't repeat often. Therefore, you have to use intervals, which is called bins in statistics, to collect the data. So when we're looking at histogram, there's a couple things that you could be talking about. The class, which is the range or interval of the values that contains the data items. The class boundary is a value that is halfway between the largest number of one class and the smallest number of the next class. And so halfway, again, would be taking the average of those two. The class width is the difference between the class boundaries, so the smallest number and the largest number. And then the frequency is the number of data items in that class. Let's look at an example. Here we have a histogram with weekly incomes. We can see that the income ranges are 300, to 399, 400 to 499, and so on up through 800 and 899. The frequency is given for each, and this was from a randomly selected group of people. So again, the vertical axis would be the frequency. How many of those people fell into that category? How many classes of incomes? Well, each one of the ranges listed are from 300s up to 800s, which gives us 6 classes. And the class width would be how many, in this case, dollar amount, is it from 300 to 399. So again, if we consider 300 that first point, it's not just 99, but it's actually 100 for our class width, because 300 would be the first dollar amount in that class, and 399 would be the 100th dollar amount in that class. So we have class width of 100. Okay, so now let's take a look at some scenarios and state which graph would be more appropriate than the others to use to display this information. If we have the amounts of 6 different items in an inventory stock, we're comparing different amounts, so that would be a bar graph. And so if you looked at the bar graph, you could see which items were low on the inventory. The amount of income a company had at the end of each month for years, so we want to see trends and look at the comparison for January, February, March, so on. And so a line graph would be a good choice here because then those data points are connected. So again, you can see the trend of the income. Weights of 100 gallon apples grown in the same apple orchard. So here we could get pretty specific in the weights, and I'm sure the exact weights are not going to repeat very often, especially if they're maybe weighing in milligrams and things like that. So you would want to group the weights together, which means a histogram would be the best choice for that one. And then for the last one, the division of your paycheck between federal, states, health, and take-home pay. So we're dividing our paycheck into parts. So that would be your circle graph or your pie chart. So again, the keyword there to help us with that would be the division. We're breaking up our entire paycheck into those categories. Now let's look at another type of graph. A pictograph is a graph which uses images or icons to stand for a set amount of items. Pictographs have similar style to bar graph, except instead of bars, they use images to represent the amount in each category. As with bar graphs, the size of the icons used in a pictograph should be the same for each column. If the icons are different sizes, the representation of the data could be misleading. So let's take a look at an example. So here we have DVD symbols representing the amounts of games sold. And notice that each column has the exact same size of that DVD symbol. And if we look at our answer key or key for the graph over here on the right-hand side, we see that one DVD symbol represents 1 million copies of the game. And so if we look at the Xbox bar here, we see that at the top, the symbol is cut and it looks like almost in half. So we can assume that half of the symbol, notice they didn't shrink it down to half the size, but they kept the same size symbol and they just cut a portion of it off, would represent half of 1 million copies, which would be 500,000 copies, or again, 1/2 million. Then it asks approximately how many copies of Skyrim were sold for PlayStation 3. Well, if we look at the PlayStation 3, we have, it looks like a little bit shaved off of that top one, but still it's really, really close to 3 million. So we'll say it's approximately 3 million copies. And so that shows one of the limitations displaying data with a pictograph is that it isn't very accurate for specific figures, meaning numbers. So we don't know exactly how many that represents. We can give an estimate, but again, if we needed exact numbers, we would have to look at some other information. We can't just read that from the graph. Okay, now it's your turn to practice using a pie chart. And notice for this one, we have not just percent, but the amount budgeted. And so again, if you look up here to the description, it tells you that the total income is $2,800. And so, for example, the rent is 24%. And so if we want to look at what dollar amount that is, we turn it into a decimal as 0.24 and then multiply it by your 2,800 budget to see what that dollar amount is. Okay, so go ahead and work through these problems and check your answers. Notice 9 has you combining categories together and 10 has you excluding category. So make sure that you're reading the question carefully and answering what it's asking. When you're ready, we'll look at some of the story problems together. So our first one, we're given a bar graph. Barbara's Bombastic Bakery provides nutrition information for the different baked goods sold. A small poster on the wall displays the number of calories per serving of different cake flavors available for custom cakes, and it doesn't include the frosting. So we can easily read the information on this chart so we can answer the questions. Which flavor of cake has most calories per serving? So again, it's easy to see. We won't have to sort through data. We can just look at the tallest bar. In this case would be chocolate, which I did not want to know that because that's probably what I would have gone for. And then our second question, what is the approximate difference in number of calories per serving between the cake with the most calories and the cake with the fewest calories per serving? And again, notice it says approximate, so we're going to use our best guess, educated guess, based on our numbers. And so the most we already mentioned was the chocolate. And so if we look across our bar here, it's not quite at 350, but it's above the halfway mark. It's above 325. So let's estimate that the chocolate cake is 340 calories per serving. I hope those servings are large because I like cake. And then the smallest, the lowest bar would be our strawberry, it looks like. And so if we took our strawberry across, and as you can see, I don't draw very straight. It looks like it's about 250 calories. And so if we do the math, that's about a 90 calorie difference. So again, the actual specific numbers might be different, but this is just an approximate or an estimate of the difference. So as long as when you're doing a problem like this, your answer makes sense, then it will be fine. If you approximate it as being like 300 calories, obviously that would be way too far out of the numbers that make sense to what the graph is showing. So make sure you look at the data and make your best estimate. If the bar graph was adjusted to include an additional 80 calories per serving of frosting for each flavor of cake, would that change which flavor had the most calories per serving? And so it says to each flavor, so no, all cake flavors would be 80 calories more. So chocolate would still be the highest and strawberry would still be the lowest. Okay, let's look at this line graph. Sometimes this is referred to as a double line graph because we see two lines of information or data shown in this one graph. And this one shows the highest and lowest recorded temperatures in Houston, Texas for January through June, or the first 6 months of 2013. So during which month was the difference between the highest and lowest temperatures the greatest? So we're looking for where the two graphs are the furthest apart, and it appears we could do the actual subtraction if we wanted to. But just visually we can see that there's a pretty big difference here. It seems definitely to be the most between March and April. Or I'm sorry, between the highest and the lowest in March. And what trend do you notice about each line? So again, there is some up and down movement of the graphs when you look at specific from one month to the next. But we can see that the overall feel of both of the lines is that they are both increasing. And so the trend, we can say that there is an overall increase in temperature over time. So again, there might be a couple months where the high or the low temperature dropped a little bit, but overall it's increasing as the months progress. Which 2 months did the high temperature decrease the most? So we're just looking at the high temperature, which is the darker line, and it wants decreased. So if we look from 81 to 79, there's a slight decrease, and we have an increase. And then 90 to 85 is a decrease, and then we increase again. So there's only 2 places where it decreases, and March to April has a steeper decrease, the more amounts. Between which 2 months did the low temperature increase the most? So low temperature, wrong button, would be the light blue and increase the most. Again, when we look at the line, we have increase, decrease, increase, increase. And then notice from the 42 to 68, the slope of the slant on the line goes up quite a bit more. So May to June is where the temperature increased the most. Here's a circle graph, calorie sources of Greek-style yogurt. And so again, we're looking at the total calories. And it says there are 130 calories in a serving. How many calories come from carbohydrates? Well, carbohydrates, we can see, is the medium color blue, which is 12.4%. So as a decimal, it would be 0.124. And we have to multiply that by the total amount of calories, which is 130 calories. And that tells us that there's 16.12 calories from the yogurts in the carbohydrates. What source provides the most calories per serving? So we're looking at the largest percent or the largest piece of the pie, which is the lightest color, which is the fats calories. And then how many total calories come from the proteins and the carbohydrates? Well, let's go ahead and add their percents together. So the protein is the 33.8%, so it's a decimal 0.338. And the carbs, the carbohydrates was our 0.124. So when we add those together, we get 0.462, almost half of the calories. And we'll multiply that by 130 calories per serving to get 60.06 calories come from both the proteins and carbohydrates together. Okay, here we have a histogram. Histogram shows prices for a 1-bedroom apartment near Charleston, South Carolina. And again, the actual dollar amounts can vary so much. We grouped them together in $100 increments. And so how many classes are represented? We have the 600s, 700s, 800s, 900s, 1000s, and 1100s. So there are 6 classes here. The width of each class, again, from 600 to 699, for example, would be $100 spread. How many apartments total are in the data set? Well, that one we have to figure out. Let's look at the frequencies. So our first frequency in the 600s was 3. Then we have 6, 2, 7, then another 2, and a 1. So we get a total of 21 apartments. in our data sets. And which class has the highest frequency? We would see that the tallest one was at 7, so that would be the $900 range. And so we could expect that to be where the asking price is for a majority of the apartments for us, which if we look at 7 out of 21, which is about a third. Okay. For number 15, it points out a really good idea for us. Sometimes the scale of a graph can affect your interpretation of the data presented by the graph. The following data on the monthly unemployment rate in the United States, taken from the Bureau of Labor Statistics website from September 2013 to February 2014, is as follows. And so both of these graphs are representing the exact same data. So how do the vertical scales differ? If we look at graph A, it is counting by tenths. So it starts off with that 6.3 and goes up. And then if we look at graph B, when we look at the vertical scale, we see that it is counting by whole numbers. It starts off with 0 and goes up through 8. So we're counting by 1. And as you can see, it makes a big difference on how the graphs look. So if you wanted to demonstrate how the employment rate has dropped significantly under the current administration, which graph would you choose to show? So let's say you're running for re-election and you want to say how good things are going with you in office. We would want to look at the one that's more impressive, which would definitely be graph A. But if you wanted to demonstrate how the current administration hasn't significantly reduced anything, then you want to look for the least impressive one. So maybe you're my running mate. You would want to represent it with graph B, which again, the numbers are still the exact same numbers, but the visual representation definitely looks significantly different. And as far as one showing a decrease, graph A, hands down, looks way better if you're trying to show that decrease. Okay, so again, it's really important when you're looking at graphs for your own personal use. When looking at things, you need to figure out, what is the bent, what is the slant, what is the purpose of the person who created the graph, and how is that affecting what I see. So you have to be realistic in what you look at, okay? So again, any questions while you're working on your homework for this section, send me an email. Be happy to help. Otherwise, I'll see you next time.